All right, so we're going over problems from lesson 8. Have your textbooks open, please, to pages 42 and 43, so you have those problems in front of you. I'll start taking requests for problems you want to go over. Yes?
17.
Number 17. All right. 7 minus 4 minus 5 plus 12 minus 2 minus pipe negative 2. Pipe. I copy that correctly? Looks like it. Once you get set up, please take out 8 so I can check it.
You
All right.
want my corrections?
I'm sorry?
My corrections.
Yeah, if you have corrections, you can just put them on my desk. What are we going to do first here? That goes to you guys also. If you have corrections, you can put them on my desk. Guys who are at home, if you have corrections, you can take a picture and upload it and email it to me. Okay, so plus what? Okay, yeah. So we'll take these. We'll take the subtraction, convert to plus negative. So 7 plus negative 4, and then what?
Negative 5.
Plus negative 5.
Plus 12. Plus negative 2.
Now what happens with this guy here?
Plus 2.
No.
Oh, plus negative 2, sorry.
Right, because the pipes mean take the absolute value of that. So we can think of this as plus negative pipe negative 2, which is going to become the negative 2 inside the pipes just becomes 2, and that negative on the outside is still there. Be careful. You can't cancel negative signs across the pipes. You have to do what's inside the pipes first.
Oh, okay.
So that last one becomes negative 2, and then at this point we just add together our negatives, 4, 5, 2, and 2, and we get 13, and we add together our positives, we get 19. 19 plus negative 13 should give you 6. Should be your answer.
Yeah, that's right. Thank you.
Yep.
Thank you.
All right, any others? Yeah, be careful with the pipes, please. That's a common thing that I see. Any others? Yep.
Number 27.
27. All right. 27. We're multiplying together 3 mixed numbers. 27. We've got 3 2/3 times 1 4/5 times 2 3/11. In order to multiply together mixed numbers, what do we have to do? The first thing we have to do.
Simplify.
What do you mean when you say simplify?
Dividing. Like 2 divided by 4, 3 divided by 3.
No, so the problem with mixed numbers is that we've got 2 different things going on in them. We've got a whole part, so if you look at the first one, we've got a whole part, the 3, and then we've got a fractional part, the 2/3. When we're adding or subtracting mixed numbers, this isn't such a big deal because we can add those together separately. Right? 3 2/3 means 3 plus 2/3. So if we're adding it to other mixed numbers, this already means 3 plus 2/3, so it's not a big deal. The problem is when we go to multiply, that we've got 2 different kinds of things here. We've got numbers, we've got integers, and we've also got fractions. And multiplying those together is going to be a pain. So what are we going to do to make sure we only have one type of number going on here? When you're multiplying or dividing mixed numbers, you have to do what first? Convert them into improper fractions. So what are these 3 fractions?
Oh, you multiply the whole number by the denominator.
And then?
Add it to the numerator.
Right. We multiply together the denominator and the whole number. We get 9 here, and then we add 2, gives us 11 over 3. Why does that work? Because we've got 3 whole pizzas and then 2/3 of a pizza. So we take those 3 whole pizzas, we cut them into thirds. 3 whole pizzas cut into thirds is 9 thirds. And then we've got 2 more thirds. So add them together, we get 11 thirds. All right, 1 and 4/5 becomes what? 9 over 5. 5 times 1 is 5, plus 4 is 9. You always keep the denominator the same. 2 and 3/11 becomes
2 and 3, 25 over 11.
25 over 11. All right, now, when we multiply fractions, what do?
You can simplify it now.
We can simplify before we multiply. What can we simplify?
3 and 9, 5 and 25.
So 3 and 9, what do those become?
3 and 9, 1, 1.
Yeah, we divide them both by 3. What else can we do?
5 and 25.
5 and 25, what do those become?
1 and 5.
1 and 5. What else can I simplify?
11 and 11.
11 and 11, those both become
1 and
1. All right, so now we multiply across the top and multiply across the bottom. We multiply across the top, we've got 1 times 3 times 5 is what?
15.
15. Multiply across the bottom, 1 times 1 times 1
1.
is 1. 15 over 1, just write that as 15. So make sure that when you're multiplying or dividing mixed numbers, treat them as fractions. Change them to improper fractions, and then do your multiplication or your division. Other ones from problem set 8 that you want to go over.
26. Is that? No.
Yeah, 26 is on the list. 26, okay. 8 and 1/8. I love reviewing these sorts of things with fractions because fractions are probably the single thing that gives students the most difficulty in this class. So we've got 8 and 1/18, minus 2 and 1/6, minus 4 and 1/3. Now here we have what? What kind of things do we have in order to be doing to them?
Fractions with separate denominators. We need to make them common denominator.
We've got fractions. We don't just have fractions though. What else do we have?
Mixed numbers.
We've got mixed numbers, right? So the thing we can do with mixed numbers is we can treat them separately. But you're right that when we add or subtract the fraction parts, we need to make sure that they have the same denominator. So how can we rewrite these to make all the fractions have the same denominator?
8 and 1/18, 2 and 3/18, and 4 and 6/18.
Yes. So we've got 8 and 1/18, minus 2 and 3/18, minus 4 and 6/18. Now, if we try to subtract the whole parts and then the fractional parts separately, the problem that we're going to run into is what? So 8 minus 2 minus 4, that's easy enough to do. But what about 1/18 minus 3/18 minus 6/18? What are we going to end up with? 1/18 minus 3/18 minus 6/18.
2 and 4/18. Oh, you're gonna have to borrow from the.
We're going to have to borrow because if we do 1/18 and we take 3/18 away, we're going to end up with a negative fraction. We're allowed to have negative fractions, but it's going to be a problem if we have a positive whole number and a negative fraction. So we're going to borrow. So instead of writing 8 and 1/18, what are we going to write?
7 and
7 and 19 over 18. We took one of these 8 whole pizzas and we cut it up into 18 slices. So then we've still got 7 whole pizzas, and then of 18s, there's a one pizza's 18 slices, and then there's another 18. All right, now minus 2 and 3/18, now minus 4 and 6/18, and we can subtract the whole parts in the fraction.
1.
1. 19 over 18 minus 3 over 18 minus 6 over 18 gives us
10.
10. 1 and 10 over 18. Can we simplify that?
Yes.
To what?
1, 5 over 9.
Yes, 1 and 5/9. There you go. So be careful when you're subtracting fractions, or when you're subtracting mixed numbers, that sometimes you're going to need to borrow in order to not end up with a negative fraction with your positive whole number. Because otherwise, if we did that, we would end up with 2 and and what? -8 over 18. Okay, we can't have a mixed number where one part is positive and the other is negative. It's not allowed. So we borrow one here, and then we're able to end up with a positive whole number and a positive fraction.
Number 23.
23. All right, area of the figure. Dimensions are in what unit?
Yards.
Oh. The 23?
23.
Yep. Dimensions are
Centimeters.
centimeters. 6, 3, 3, 4, 3, 7. These are all centimeters. So we're trying to find the area of this L-shaped convex hexagon. What how are we going to find the area of this? Yes? Make it two rectangles. Where do you want to cut it? Like this?
Yeah.
Okay, we'll cut it like that. So we've got rectangle 1, and we've got rectangle 2. So rectangle 1, what's its area? How'd you get 18? 6 times 3. Remember, it's length times width. And this rectangle here is 6 centimeters tall and 3 centimeters wide. So we get an area of 18 square centimeters. What about rectangle 2? What's its area?
1. Oh, we multiply that one.
Where do you get 12 from?
12.
Right? Because we're only dealing with this guy here. So its width is 4 and its length is 3. So 4 times 3 gives us 12 square centimeters. So the whole thing together is what? If this rectangle is 18 square centimeters and this is 12, the whole thing is 30 what?
Centimeter.
Not 30 centimeters.
Square.
30 square centimeters. Remember, a centimeter is a distance. It's about this long. The square centimeter is measurement of area. Since we're dealing with area, we need a square unit. Take 1 or 2 more from the homework. Anybody watching want to request one?
19.
19, okay. 19. Five minus height, -2 plus 5, height, minus parenthesis -3, parenthesis plus 2. Okay,
3.
right. Remember that the pipes, in addition to meaning take the absolute value, also count as parentheses. So we have to do whatever's inside them first before we take the absolute value of it. So -2 plus 5 gives us 3. You leave the pipes there, I guess. All right, minus -3 plus 2. All right, now what do we do?
Negative. Positive 3.
Right, so this one becomes positive 3. So we've got 5 minus 3 plus 3 plus 2. What does it give us?
Another negative 3. Negative 3. Minus 5.
5, yeah, minus 3. So yeah, so we get 5 plus -3 plus 3 plus 2, right?
Yes.
Okay, and then what's it going to give us?
7.
7. And make sure that with the pipes, you do the stuff inside them before you take the absolute value. Is there one more? Doesn't have to be. All right, turn to lesson 10, page 47. Okay. Division. What is division?
Basically subtraction, but more.
What do you mean but more?
It's a bigger step.
It's a bigger step.
It's like multiplication.
It's like multiplication, but in reverse. We could also say that it's like repeated division. We know how to make this work. There's one situation, however, where this sort of breaks down. So if we just use the example they have there, 6 over 3, 6 divided by 3 gives us what? 2. Okay, what about 6 over 2?
3,
Gives us 3. What about 6 over 1?
6,
What about 6 over 0?
0.
Not 0. Notice, the opposite of division is multiplication. So that means we should be able to multiply what we get here by the bottom and get the top. 6 divided by 3 is 2 because 2 times 3 is 6. Again, 3 times 2 is 6. 6 times 1 is 6. What times 0 will give us 6?
Nothing.
Not why.
Anything times 0 is 0.
Anything times 0 is 0. Right. If we think of this as repeated subtraction, we can subtract 0 from 6 all day long and nothing's going to happen. We can subtract 1 from 6 times. But 0, that isn't going to change it if we subtract it from 6. So, we call this
What does it say?
undefined. It doesn't have a definition for the value of that. You could sort of say that it's infinite, but it doesn't have a value. We can't do that math. It breaks division. What about sort of the other way around? What's 6 over 6?
1,
What's 3 over 6?
2. No. Yeah, 2.
Not 2. 3 divided by 6.
-2.
1/2.
1/2. Right, 3 divided by 6. How many times does 6 go into 3?
Fraction.
There's only half of it. Yeah. And what about 2 divided by 6?
Yeah.
1/3. What about 0 divided by 6? Is what?
0.
0. Anytime you have 0 on the top of a fraction, it's going to be 0 pieces, and I'm giving you 0 of them. It doesn't matter whether that pizza is cut into 2. To this is when we have this. 0 divided by anything where the fraction is the top and the bottom are the same should be 1. If it's 0, then it should be 0. And we also have this rule where if the bottom is 0, it should be undefined, this incalculably large value, really. But when we have all 3 of those things together, it really breaks. So it's not even undefined. Undefined means that this has a value, but we just can't define it. It doesn't work in our conception of math. This one, however, we're not even sure what to make of it. We call it indeterminate, because we can't even figure out what that's supposed to mean. 0 divided by 0 is even more broken than 6 divided by 0. Yeah, there's a lot of different things going wrong here. First of all, how do you cut something into 0 slices? That's one issue.
I have nothing, and I divide by nothing, and I still have nothing.
But you can't divide by nothing. Determinate, because there isn't really a clear way to determine how we want to deal with this. But anyway, know those 2 terms. The most important thing to know is that you can't divide by 0, and that 0 over 0 also doesn't work. It's good to know these terms, that anything divided by 0 is undefined, and 0 over 0 is indeterminate. This is something you actually have to watch out for when you're doing algebra, because if you're not careful about this, you can have actions where you prove that 1 equals 2, which obviously is false. But if you divide by 0, then you can accidentally prove that. It's a little early in the day for that. Okay, 2 other topics. One is very short, and the other is just a variation of something we've already learned. The first one is something that is not new, and we've talked about a few times. When we have multiplication, what order do we have to do it in? It doesn't matter. It doesn't matter whether we do 2 times 5 or 5 times 2. If we've got 5 numbers we're multiplying together, we can do it in any order that suits us, any order that's convenient. Anyone know the name for this?
Addition.
Well, this is multiplication here.
Multiplication.
It says it in the book, in fact. Commutative property of multiplication. Commutative property.
Does that mean that multiplication is able to any order?
Yes, commutative means changing around the order. The commutative property of multiplication is that the order that you multiply things together does not matter. What other operation has a commutative property? There's also the commutative property of addition. Right, both of these have a commutative property. Okay, commutative, from Latin commutare, to change around. A leech on the desk? Which one? Well, you can just, I'll take a look at it later. From Latin commutare, meaning to change around. So we can change things around, and the order doesn't matter. All right, last thing in this chapter. We've been talking about unit conversions. Now we're going to do unit conversions of area. So our unit conversions so far have been converting different lengths, converting feet to miles, or inches to centimeters, or kilometers to, say we want to do 5 yards and change it to centimeters. We'll get rid of yards first and change it to feet. We can do many steps here. So we go from yards to centimeters, we'll have to go yards to feet, then feet to inches, and then inches to centimeters, and that'll get it for us. And each time, notice, we're, the unit that we're getting rid of goes on the bottom of the next fraction. And those will cancel out. So eventually we're only left with the unit that we want to have. And we're going to end up with 5 times 3 times 12 times 2.54 centimeters. The only unit we have left. That's
Don't you have to like multiply 5 yards by itself or something like that?
sort of, yeah. When we're talking about square units, it's going to be a little bit more difficult. So if we look at the first example the textbook has on page 49, we're going to convert 44 square inches to square centimeters. Now notice, we can tell we're dealing with area because it's squared. 44 square inches, remember, means that we've got some number of inches this way, maybe it's 4 inches this way, and 11 inches this way, and so the area of the whole thing is 44 square inches. 4 times 11 is 44 square inches. Where does that square inches come from? Look at the two things we're multiplying together. 4 inches and 11 inches. What does it mean to square something? Multiply it by itself. So 4 times 11 gives us 44, and what does inches times inches get us?
Inches.
Inches times inches gives us
Feet. You know, yeah.
no, inches times inches gives us
Square.
square inches. That's what inches squared means. It means inches times inches.
So for volume, that's what it's triple.
Yes, for volume, right. We've got inches this way, and inches this way, and that's why it's cubed for volume. So when we set these up, if we're dealing with square units, it's going to be easiest if we write the unit as inches times inches, because that's what square inches means. Yes? Everyone following so far?
Mm-hmm.
Okay, we still write this over 1, just like we're setting up. And we're trying to get rid of inches and go to centimeters. We're going to set this up like we did before, but be careful. So what unit is going to go on the top of this fraction? What's going to go on the bottom?
Centimeters on top.
Centimeters on top, and that's what we're going to, and what on the bottom?
Okay.
Inches on the bottom. How many centimeters go to how many inches?
2.54. before 1 inch.
Yeah, it's 2.54 over 1. Video quality. Because, whatever. Uh-oh, now my computer's freezing.
Is that old Mac?
It's 10 years old. Isn't that amazing? I got it when I went off to college.
God.
Alright. Anyway.
It still works.
Works great. I actually dropped it again yesterday. For the second time that I sort of majorly dropped it. Okay, now, what's going to happen here? The inches on bottom are going to cancel out what? But be careful. We've only got one set of inches down here. So it's only going to cancel out one set of inches on top. What we've done now is we've gotten rid of square inches. Now we have inches times centimeters. We don't want that. How are we going to get rid of this other set of inches?
Divide. Okay.
Not by dividing.
No, because we have another set of, it's a centimeter square, so we have another set of that.
We're going to do the same thing again because we got rid of one set of inches. We need to get rid of the other set of inches and convert that to centimeters also. So again, this inches on the bottom will cancel out this inches on the top. Now what units do I have left? What units do I have left here?
Centimeters,
Times,
centimeters,
I've got centimeters times centimeters or
centimeters,
a cube. Or square centimeters, which is what I'm looking for. So my answer is going to be 44 times 2.54 times 2.54 centimeters squared. Notice, in order to get rid of square inches, I had to have inches on the bottom twice. In order to get 2 square centimeters, I had to have centimeters on the top twice. Centimeters times centimeters gives us square centimeters. You could also write this if you want, but this is fine also. So anytime you're doing unit conversions with area, each conversion has to be done twice. And later on in the year, we'll get to unit conversions of volume where you have, it's just tedious, it's not really any more difficult. Okay, so let's do quickly,
Do you have a mina new way?
a what?
A mina new way?
He was a student here last year. All right, let's do the second example they have there really quickly. We're doing 125 square centimeters to square feet. Equal directly from centimeters to feet, we'll go centimeters to inches to feet. So 125 centimeters times centimeters over 1. To get rid of centimeters, what will we do?
Lower than centimeters. Oh, we're going up.
We're going from square centimeters to square feet. So we'll go from centimeters to inches to feet.
Yeah, so inches.
Goes where?
Inches on top.
Yep. And what on the bottom?
Centimeters.
Centimeters on bottom. Okay, how many is it?
2.5.
Where?
4.
Where's the 2.5 total? How many inches is how many centimeters?
1.
1 inch is,
2.5.
right. Okay, make sure you get this lined up. 1 inch is 2.54 centimeters. That gets rid of what? How are we going to get rid of this inches here? Inches on the, what? On the bottom. And what's going to go on top? No, we're going from inches to feet. The feet on top. How many feet to how many inches? How many feet go to how many inches? 1 foot is 12 inches. Okay, let's get rid of one set of inches. I still need to do it again. Get rid of the other set of inches. 1 foot is 12 inches. That gets rid of the other set of inches. Whew! But notice, every single one of my units is crossed out except for feet times feet, which is square feet. Oh look, that's what they told me to end up with. So then we just multiply across the top. We get 125 on top. And on bottom we have 2.54 squared times 12 squared. Or you could write it out 2.54 times 2.54 times 12 times 12. And our unit is square feet. So notice, because I was doing 2 steps there, I actually have to use 4 fractions, because each one I have to do twice when it's here. Questions about this problem or this type of problem?
Is this gonna be on a test?
Not the next test. The next test is only going to go up to 8, but it'll be on the third test.
When is the next test?
After we finish 12. So let's see, we did 10 today. So 11, 12. So the test should be Friday.
Yeah.
No, it should not be Friday.
Yes, it should. I'm trying to get the test done. Can be Monday.
I don't like getting tests on Mondays because guys always forget. At 10. All right, the set of problems that you're doing is
Where we need the thingy thing.
5. Oh yeah, you start with 5 and 6. You're right. Mea culpa. Maxima culpa. Which is Latin for my bad, my big bad.
His big bad.
Not his big bad, his big bad.
Wait, can I take his folder then?
What? Yeah, that's fine. I imagine that is just abandoned, so probably, yeah. Okay, so 5, 6. What comes next?
7.
Dot.
Oh.
10. So 5 through 10. 13, 15, 16, dot. 23, so 16, 15 to 23, and then 25, 26, 27. All right. Thank you all very much for watching. Awesome. What?
Can you guess this?
Like, subscribe, and comment.
Oh yeah, I forgot to say